All right, so let's go ahead and check this out. We are finding the percentage of the area under the normal curve. So this section from here to here is 68%. Now, notice here it says the right half of the curve from 0 to 2 standard deviations is 50. From here all the way over here is to 50. We're chopping this off right here. And in fact, this section is really only worth 13.5%. So this is 34% here. So 34, 34, and 13.5. So the actual answer should be 81.5%. All right, so how many standard deviations above or below the mean is an employee? This is asking for the z-score. The z-score is the number of standard deviations away. So formula, here is the not that bad. Let's see, 48 is our x bar, and 9 is our standard deviation. So I'm supposed to take what I'm comparing minus my average divided by my standard deviation. And when I get that, I get negative 2.78. So my answer would be 2.78 standard deviations below. And that would make sense, because if here is 48 and I have a standard deviation every 9, 23 is going to be way over there. All right, what do we have here? So we are finding, or we're given the average. We want the average to be this, and we're trying to figure out what our fifth score needs to be. So if I add 1, 2, 3, 4, 5, I don't want to divide by 4. I want to divide by 5. I just don't know what the fifth one is yet. So then my math becomes that I'm supposed to multiply by 5 here, which gives me 876 plus x is equal to 1125, and so x is equal to 249. So I need to get at least that. Now hopefully you recognize that that just doesn't really make any sort of sense there, because if I want my average to be 225, if I had a 24, that would really bring down my average. So hopefully that makes some sense of why that wouldn't be true. All right, here is our last one. So this we are considering which one has the largest standard deviation. Now, even here, we didn't actually find the standard deviation on these, but you don't need to completely find the standard deviation. What you do need to do is to figure out how this here, these are all our averages, right? Average, 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 average. Those are all of our means. So here, if this is our mean, then this is 3 away, 3 away, 0 away, 3 away, 3 away. Hopefully you understand what I'm talking about there. Again, 8 is our average, and these are all the distances away from that average. This one here is 3 away, 0, 0, 0, and then 3 away. Here is 3 away, 1 away, 0 away, 1 away, 3 away. And here my average is 16, so I have 3 away, 1 away, 0 away, 1 away, 3 away. So these are both the same. And these are a little bit more than that. This one here is the biggest one because this is all the numbers. So what I'm going to do is I'm going to square all of those, and I'm going to divide by 5, etc. Whereas if I square all of these and divide, I'm going to get a smaller number than if I'm using all my 3's versus my 3's and my 0's and my 1's. So this has the biggest standard deviation because they are more deviating from our mean.